Okay, let's have a look at question 3. Again, we're going to use our graphics calculator to help us here, but also our basic knowledge of our functions. So we've got population of water buffalo. T is the number of years since the first estimate was made. What was the initial estimate? So once again, initially, that is when time equals 0. So we're using our substitution, fancy pants notation, P of 0. And all that means is wherever T appears in the equation, let's just replace it with 0. Okay, if it had P of 10, well then wherever T is, I'd replace it with 10, etc., etc. So sine pi times 0 all over 2. Again, do we need to go to our calculator here? Because we know 0 times anything will be 0. And what is sine of 0, right? That's 0. Again, how do we know that? It's because we know our sine function, it's starting at 0 there, or we know our unit circle. And at 0, what's the height? So there's our 0 here. What's the height? It's 0. Okay, so and then 250 times 0 is 0, so we're just left with 400. Okay, so we've got 400. Let's make sure we're being pretty good here. Buffalo. Answer the question nicely. What was the population size after 6 months? Be careful here because, being a little bit sneaky, T is in years. So when we're saying 6 months, that means T is actually going to be 1/2. So I'm going to use the calculator to do this, but I'm still writing down what the question is actually asking me, just in case, I do something kooky on the calc. It's been known to happen. So we're going to say pi times 1/2 all over 2. Okay, and then obviously for 2 years, that will be P of 2. And make sure that you substitute that in, okay? So wherever the T was, we replaced it with the 2, and 2 divided by 2, they just cancel each other out. Okay, and again, probably don't need our calculator for that, because sine of pi is 180, so sine of pi is a 0, so that's going to, so I predict already that one's going to be 400 buffalo. Anyway, let's use our calculator to work this one out. So we go 400 plus 250 sine, put our bracket, and we'll say pi times. Now, it says t, but we're just going to use x because the calculator is saying that's our variable. Close our bracket. Okay, now I've got a previous scale in from the question that we did before. So what are we going to do for this one? Okay, we will go shift view window. Now it's still starting at 0. I'm happy with that. Okay, but will it go? It was 39 and something, and you can see clearly my maximum, because it's 250, that means it's going to go from 250 to minus 250, and then I'm adding 400. So I know my maximum is already 260. How long is it going to take to complete one cycle? Okay, so once again, even though it hasn't asked me to, I'm going to work out the period of that function. So period is 2 pi. I'll just do it in a darker color so you can see there. Right, so period is 2 pi over b, and so that is going to be 2 pi divided by, right, what's the coefficient here? It's pi on 2. So it's divided by pi on 2, which means that's 2 pi times 2 over pi. The pi's cancel, and we've got 4. So when it comes back to my scale, right, I'm going to change that, go to 4. Still not going to see anything. I'm okay with that, because now I'm going to go shift, zoom, auto. And there we go. I think I said in a previous video that I really like to see my buffer, my x-axis, but in this case I think it's going to be a little bit silly because the maximum is 650. Might look a bit kooky, but prepared to give it a go. So you can pop 0 there, give me a buffer, so 655. Not too bad, that's okay. So do you have to do that? No, you don't. As I said, I just like to see where my x-axis is. Sometimes it's not possible because it just looks too silly, but in this case it's okay. All right, so what we're doing, we wanted to find p of a half, so we're going to go gsolve more ycalc and pop in 0.5 equals 576.7. So go back to my light blue, 576. Now, you know, this is where you can have a little bit of a debate. How do you round? Are you going to round up because maybe this is a buffalo that's about to give birth, or are you going to say no, it's the actual number that we have? So it's up to you whether you want to put 576 or 577. I guess we could have that debate in class, but I'm okay. Find p of 1. Right, so using our notation, right, p of 1 again, that's going to be wherever t appears, we're going to replace it with 1, so 250 sine pi times 1 all over 2, and we could go to the graphics calculator, run mode, and type that in, but while I've got the graph, I'm going to go gsolve more ycalc 1, enter. Right, so now we've got 650. And what about D? Find the smallest population size and when it first occurred. Now, I think we could find the smallest without using our calculator, but to know when, that's going to be a little bit harder. Okay, so because it's 250, I know it's minus 250 plus 400, so I know the minus here, the minimum is going to be minus 250 plus 400. But anyway, don't strain your brain. We go gsolve min. Right, so after, when t is 3, and what was t again? Years. So after 3 years, your minimum is going to be 150. So answer, we'll find the smallest population size. So the smallest size of the herd will be 150 buffalo. Okay, and when this occurred, at 3 years. Find the first time when the herd exceeds 500. So, oops, go back to that. 2 options here. You can go gsolve more, and we can say xcalc when y is 500. Okay, so 0.26 of a year. Alternatively, you can pop in 500 in your y2 and gsolve intersect, and you get the same thing. Again, it's a visual. So 0.26. So A, B, C, D, E. So when is the population greater than 500? That's going to be when t equals 0. What was that? 262? 0.262 of a year. I guess we can say, what is that? Just a little thing, by the way. So what was it? 0.262. Press your x value, press enter. Can you see that comes up? The value that you just had. So anyway, how about we take that answer and we times it by 12 months in a year. So 3 months, 3.1. We'll just go 3.1 months. Oops. Hey, months. Okay, so there you go. Trying to get used to how to use your calculator, how to understand what the graphs look like, how we can use our amplitude and the vertical translation to help us answer those questions.